So we have our first ROS talk of the event, which would be presented by Yuvraj Mehta from Orangewood Labs. He'd be speaking about RoboGPT, that's an AI-driven robotic arm control with ROS and LLMs. He'd overall explore the integration of LLMs and simulation tools in ROS for robot control and skill learning. And you'd be more or less able to understand how ROS-based perception, AI-driven task control, and virtual environments for testing can work about. So I'll hand over to Yuvraj. Please be a nice attendee panel and support with him with maintaining silence. Thank you.
Good morning, everyone. This is Chetan. I'm Chetan Patil. I lead software and AI team at Orangewood Labs. This is my colleague Yuvraj Mehta from our team, and we will be presenting RoboGPT, which is AI-driven robotic arm control with ROS and LLMs. I think many of you might have heard about what Orangewood Labs we do. What we do at Orangewood Labs, we manufacture indigenous robotic arm based in India, and we are building AI to control the robotic arm. We are building AI to control the robotic arm. So that is where RoboGPT comes in. Okay. So I'll just give you a quick background about this. So I think most of you are aware, robotic arms have been in the industry since many years, and controlling robotic arms is one of the biggest hassle. And similarly, so it needs coding languages as well as teach pendants, which are traditionally available. Only trained people can do the training, and there is a technical gap exist in the market. Now, with the power of AI and generative AI, which is the recent development in the sector, AI has given robotics power so that any layman can operate the robotic arm. Now, I think there is one glitch here, but yeah. So our motive at Orangewood Labs is to make robotics accessible for everyone. Now, the simple example is obviously the traditional robotic arms. They are not ROS enabled, and most of the ROS engineers, they are not aware about the traditional architectures, or they have not used that the traditional robotic arms. So we are here to bridge this particular gap, and RoboGPT exactly does the same job. The most important point here is we want to fast forward the research so that it can integrate with different tech stacks which is available in the robotics seamlessly, so that most of the robotics engineers like you and many other people, they don't have to spend significant time in the development. So like I think earlier question was also raised that many students have to go through the whole semester just to set up and just to learn those things. Now, the idea here is people should focus more on the applications and the algorithms and not spend time on the integration. RoboGPT solve this particular problem. How many of you are AI developers here? I would like to quickly understand. Right. And how many use AI for robotics development? Nice. So actually, AI at core is also significantly important for the robotics development, including VLMs and VLAs. That which comes as a next step in this particular RoboGPT's roadmap. I'll just quickly share few. So there are many features of the RoboGPT, but I'll just share quickly two main features. One is speech to action and skill training. It's not the spell. You please pardon the spelling there. It is so whenever we give any prompts in the natural language, the arm can able to execute those tasks. And I'll like to little brief about what is skill training using templates. So every setup is in physical world, it is fixed in certain way. Now if a human is able to teach a robotic arm for that particular space, for example, let's say this is a particular booth and there are certain objects, then it is possible that human can teach the robotic arm, and so that robotic arm can, with the vision system and LLMs, it can execute the whole tasks. So there are multiple approaches on how we use AI to power robotic arm control. One is, of course, the foundational model, and another is the skill training. There are, even I understand, there are more approaches which are not yet revealed in the space because it's a black box till now. So RoboGPT is the product which facilitate this complete process, and using just the natural language prompts, you can teach, let's say, for example, if there is a robot in a restaurant or robot in a booth, so those particular tasks can be automated using this particular platform. Just what it does, to elaborate that, I'll just play the two videos here. Can you please play the video?
Pick up the cereal box and place it in the accepted menu.
This is a simple example, which was very like we had done. This is Orangewood's indigenous robotic arm. The voice control demonstration is the same. The important one is now, this one is a drink bot, which you will get a flavor of how the whole task is getting trained for robotic arm and it's getting executed. Can you play the second video?
Hi there, welcome to RoboGPT. Start chatting now.
I think you can continue the video. The video can play. So the whole prompt is elaborated, and it should contain all the positions of the objects, or some, for example, if some objects are not being recognized, then humans can correct those objects basically. And just by consecutive prompts, if robot does not is not aware about a particular skill, then it can ask the human what is that skill or what is that object, and then it can rectify or rather register that in its memory and execute that. Now screwdriver is, for example, one drink, and now it can now it knows which are the ingredients which are required for this particular drink versus another drink, and it will provide the drink to the customer. Likewise, this drink bot, instead of drink bot, it can be any ice cream bot, or it can be any restaurant bot. It's possible.
Enjoy.
Thank you. So, just to give more details about the architecture, I'll hand over it to Yuvraj.
So, hi everyone. So now let's just discuss what's the under the hood of this RoboGPT. Currently, like you might like think about it, it's just a single code base or single ROS package, but no. RoboGPT is a modular structure, right? in by what I mean by the modules, all these, there are majorly 5 modules over here. First one is RoboGPT agent, then is vision stack, then we have robot drivers, simulation SDK, also known as the hardware stack, and then there's applications. All these modules are independent also, and they can also work together. They are completely there are pipelines which makes them communicate with each other. So let's just understand what these modules are. Like we just discussed the physical AI, right? It contains very different type of text to perform a particular task. If you want to for example, like in the drink bottle example, you need the vision system to detect the bottles, you need coordinates of the bottle, then you have then you need some code base to run the robot to go to that particular position. So here, first of all, we have RoboGPT agents. The agent module is the one which interacts with the users the most. It is the only model which make the sensible information out of the weird things we put in prompts. All the things we speak in the voice commands, it extracts all the things, makes sense, and then makes sense. Basically, it converts it to the understandable language for the robot, and then it picks up the applications or the skills basically. Then we have the application module. Application module is the module which contains all the skills. By the skills, I mean all the programs which will run the robot. And skills can be as simple as a simple Python program, or simple a move command for a robot. Like in robotic arms, we can just give a move command to a particular pose, and the robot will go over there. Right. This is the simplest thing we can do with a robotic arm, making a robot from moving from one position to another. And the skills can be as complex as running RL policies. So these applications or the agents, they just don't run a function, they raise a trigger particular to that skill, and that skill can contain a code base also and a single file also. Then we have RoboGPT Vision. Again, the vision stack, as its name suggests, it contains all the visual things. Visual things, by what I mean by visual things is, if you need any visual data for a task to run, like if you need object detection, you need point cloud data, you need depth images, processed images, vision, this vision module will provide you all of this. And these are also, like I said, these are independent modules, so you can only use vision module also. Just there are, like, we are leveraging the ROS services and the ROS actions, so you can just use this, call the services, and it will provide all those things. Next we go to robot drivers and simulation SDKs. Robot drivers are the one which contain different type of drivers of the different robot, as this current whole architecture is hardware agnostic. It doesn't matter if you have a DIY servo motor robot or you have a big industrial robot at your home or at your college. This will work with them unless or until it has a ROS drivers. Then we have a simulation SDK or a hardware stack. This hardware stack is, this one has a 3 modes basically. One is the simulation. If you don't have any robotic arm, you can test out all the skills, all your RL policies, or everything which needs to be done on robotic arm in simulation. Then it also provides the visualization tools. From visualization, I need, like, for the vision stack or for the other stack, if they need a context of the environment of the robot, like point cloud, or they need a TFTs, everything which is related to the robotic arm, this stack provides all those things. uh, yeah, so these modules, there are these 5 modules, but we are trying to add more modules over there, and these are independent and can also act collectively. It depends on your use case. For example, if you have a use case where you just don't need LLMs, you just don't need to give a prompt and make a robot to do a certain task, you can use only vision applications and robot drivers over there. And you need uh, if you need your robot to do particular task via voice commands or via LLMs, you can just only need use agents and that applications and robot drivers. Again, uh, so next slide is, this is just not in another OpenAI wrapper. Why I say that is because these agents, and these are not limited to a particular tech. We are not only using OpenAI, we are also uh, all these modules and are modular from inside also. You can use OpenAI API keys, you can use Cloud keys, You can even use your own custom LLMs. You can also use your custom trained models over there, because it is just a plug and play kind of thing. Second, it's also hardware agnostic. Again, you don't need to buy a particular type of robotic arm. You don't need to have a particular type of hardware setup. It works with different cameras. It works with different robots. Like all the robots which currently we are supporting our own robots, and there are a couple of other companies which are supported by RoboGPT. And as far as for the camera sensor goes, we have integrated real sense cameras. We have integrated Orbeck cameras and Z2i cameras. Then there is this thing, task replay. So every task which is done by RoboGPT is recorded. You just don't need to like again reprogram everything for a different type of robotic arm. For example, if you have trained a particular skill, or you have trained the whole your policies or whole skill set or whole task on a particular DIY robot, a servo motor, then you have to change your robot to a different type of robot, given that it's a 6 degree of freedom. Or you can, then you just don't need to like again write all the things over there. You can just use the whole recorded things. It records the Cartesian coordinates and all other data, so it can adapt to the new robotic arm based on the robot drivers. All the uncertainties are handled by these blocks only. uh, then again, this question, why are we using ROS for this? I don't think so like there is any need for answering that, because ROS is like it provides many. First of all, it's a universal platform. There are many. The community is very big for the ROS developers. Secondly, it provides simulation. This is very simulation friendly, so you can just leverage the whole modules over there and can simulate a multiple skills in your simulation environment. Then there is this cross language compatibility. Cross language compatibility is like, for example, if there are robotic arms, there are new. We are saying we can work with different robotic arms. So there are some robotic arms which have their SDKs in different languages. So we don't need to convert them into our software language, like the language which we are using in the whole software. We can just communicate with these two. The robot drivers can communicate with the robotic control stack via ROS messages and all those things. Second, there are modular and debugging tools. There are other options for intercommunication, like there are gRPC and MQTT, but we are using ROS because it provides many debugging tools over there. Many tools which, like for example, RQT graph and RVs, these are the tools which we can leverage for debugging. Uh, Next up, we have future and beyond. Like this will be explained by Chetan.
So as you've seen, there is a need in robotics for a platform which can integrate with multiple tech stacks, multiple robots. So there are multiple LLM models, VLM models are there. Now, Vision Stack also has continuous developments. Now, if the research needs to keep the pace with the latest development in individual area, then obviously there is a need for a platform base where uh, those things are modular and plug and play. So that not every person has to spend, let's say, 6 months or 12 months of time just to do the basic integration task. And that's the point where RoboGPT helps the users and like researchers or customers. There are obviously RoboGPT has multiple areas of future development. One clear area is the foundational model for industrial applications. VLAs and VLMs is very important, and hence real-time data collection, because that will help power the robotic arms. Skill training. So, see, for example, every application has unique skill. So there are certain core skills which we already provide in the robotic arm, in the RoboGPT. For example, moving, or let's say, for example, getting positions. Let's say, for example, drink bot is one skill. Now drink bot is already there. Similarly, popcorn making is already there. Now new user need not train the same drink bot or same popcorn. Basically, even if the positions of the objects are different, with the vision stack it can recognize that, and it can execute without any modifications for that. And since more and more skill addition will improve the RoboGPT's obviously adoption as well, and similarly uh, the academic partnerships are very important because it helps the researchers as well as it is win-win situations for both the parties basically. So yeah, that's the future about it, and I think that's the end of our presentation as well. Thank you.